Hey, Algebra 2 students, this is extra practice on using the quadratic formula to find the zeros of quadratic functions. And this goes with lesson 12a in your core Algebra 2 class. So that's from the first half of lesson 12. All right, so this skill is pretty procedural. We're using a formula that'll work for any kind of quadratic equation. So a quick reminder, this is an example of a quadratic equation. Something that looks like ax squared plus bx plus c. And this is a typo that we all need to fix. So if you're using this handout, please fix this typo. This shouldn't be a positive 7. It should be a negative 7. All right. Again, this is pretty procedural. This will be a relatively short video. The steps that you need to follow to use this are right here. We have to first make sure our equation is set equal to 0. So if we're finding zeros of a function, that's what we would do. Here on our example 1, that's true. It is some quadratic ax squared plus bx plus c equal to 0. If it weren't, we may need to fix that. There's an example of how we would first subtract or add a number to get it equal to 0. Next, we have to determine the values of a, b, and c. So again, once we've written the general form next to it, reading off the values is really straightforward. In this case, a is just the number that's being multiplied by x, so it's going to be 2. B is the number that's being multiplied by the x term, the linear term, so that's going to be negative 4. And c is the term that's being our constant term, so this will be negative 7. Once we get our values of a, b, and c, we just have to plug in the values to our formula. Here's our quadratic formula. It should look familiar to a lot of people. If I'm going to say it's going to be equal to, what I like to do to help myself plug these values in very accurately to our formula is I open up spaces where I'm going to plug in each value. So for example, on top we have a negative b, but instead of writing b or the value, I'm just going to put a space, a blank with parentheses, where I'm going to eventually fill in my values. That'll really help me keep the signs, the positive and negatives, correct in my solution. Plus minus, so then we have square root. Again, this b, I'm just going to put a blank squared, so it's going to be something squared, and then minus 4 times something times something. And then on bottom, we just have 2 times something. Now I'm going to fill in our values where the b's are. B is equal to negative 4, so I'm just going to plug a negative 4 in. Where an a is, it's just going to be 2, 2, 2. So I'm going to actually highlight these so it's clear that the b's are negative, the yellow. A is the positive 2. And then the c is going to be the blue, which is negative 7. So we've just very carefully plugged in each of our coefficients into this formula. The rest of our job is just going to be to simplify this resulting radical and then get our solutions at the end. So to do that, I'm going to start by rewriting on a new line. I'm going to simplify starting up top over here with this negative 4. A negative 4 is actually like a positive 4. Then we have plus or minus the square root of negative 4 squared, which is negative 4 times negative 4, which is 16. So that's going to be 16. And then we have minus 4 times 2 times, I'm going to do this all in one group. 4 times 2 times negative 8, or times negative 7. That's going to be 8 times negative 7, which is going to be a negative 56. So we're going to have a minus, and then those 3 terms multiplied give us negative 56. On bottom we have a 4. All right, continuing to simplify. I notice inside the radical next, that's kind of hard to see. Inside, underneath our square root, we can simplify this next. So we got 4 plus or minus the square root of 16 minus a negative 56. Again, minus a negative 16, it's the same as 16 plus 56. Minus a negative is a plus. So that's going to be a 72. And then divide by 4. So we're pretty close here. To finish solving this, we're just gonna, in this case, we're gonna simplify into decimals. So we could factor out that square, or we could rewrite this square as a perfect square and try and factor it out, but instead we're just gonna write it as a decimal. So it's gonna be 4 plus or minus, and then I'm gonna put square root of 72 in a calculator. Doing that right now. Square root of 72, which is 8.485 all over 4, and that's going to give us, now this is pretty much as simple as we get. We have to do each of these, the positive version and the negative version, separately. So this will give us two solutions, one where we add our terms and a separate solution where we subtract them. So if we added, we would get x equals, this has all been x equals this whole time, x equals 4 plus 8.485 all over 4, and on bottom we get x equals 4 minus 8.485 all over 4. Simplifying, that's going to be 12.485 all over 4. That's a 4. And on bottom we get negative 4.485 all over 4. And then .121. On bottom we got negative 4.485 divided by 4. It's negative 1.121. So overall we got two solutions, which is good because that's what we expect. We expect to have, for a quadratic, something with degree 2, like this one, we would expect to have two solutions. So our solutions here would be x equals 3.121 and x equals negative 1.121. One solution, another solution. All right. And then lastly, we could write this in factored form. I'm not super worried. Actually, we're not very worried about this right now. We'll come back to this later on. So let's just practice finding the zeros of this function one more time. So at this point, you've seen a walkthrough. You have this walkthrough up here of all 4 of the steps on a different example. And then in example 2, what you should do now is pause the video, take a few minutes, and try this out. Follow the steps 1, 2, 3, 4. Then as you finish or as you get stuck, play the video and check yourself and make sure you're really clear about how to do this. So hopefully you've tried this out, but right now I'm going to go ahead and walk through this. I'm going to go kind of quickly since I'm counting on you having tried it out. F of x equals this. It says find the zeros of the function. So the zeros of a function are where a function is equal to 0. Now looking at this, I see we have a quadratic, x squared minus 5x plus 5 equal to 0. We know that, like we should know now, that we can solve this using our quadratic formula. To start us off, I write the general form underneath, ax squared plus bx plus c. In this case, a is the coefficient on x squared, so the number that's being multiplied by x squared. Here there is not one explicitly written out, but we do know that there's a 1. There's 1x squared, so that's a 1 out front. So a is going to be equal to 1, b is going to be equal to negative 5, and c is going to be equal to 5. Okay. We have our coefficients. That's kind of like our step 2. Check. Step 3, we just have to plug them in. All right, that's easy. X equals negative something plus or minus the square root of something squared minus 4 times a times c all over 2a. And so x is going to be equal to negative 5 plus or minus the square root of negative 5 squared minus 4 times a times c all over 2a times 1. All right, simplifying this a little bit more, x is going to be equal to just a positive 5 plus or minus the square root of 25 minus 20 all over 2. And again, it's a positive 25 because negative 5 squared is negative 5 times negative 5, which is positive 25. And then this is 20 because 1 times 4 times 5, 1 times 4 is 4, 4 times 5 is 20, all over 2. So let's take one more step, simplify under the radical. We got 5 plus or minus the square root of 25 minus 20 is just 5, all over 2. And so now we have basically like a couple options. There's a lot of ways you can write your solutions to this. One option is you can write it like a decimal as we did in our other example. You could write it as x equals 5 plus root 5 all over 2, or x equals 5 minus root 5 all over 2. Like that's a pretty simple radical expression. We could split it up into two fractions. X equals 5 over 2 plus, so we divide those first two, also divide the second two, plus square root of 2 all divided by 2, or x equals 5 all over 2 minus square root, oops, I copied this down wrong. It's a square root of 5 in both cases. So back up here, this was a square root of 5, square root of 5. Right, it's 5 all over 2. Or we could write them as the decimal. So in my calculator, I'm going to put in 5 divided by 2 is, I'm just going to put them both all in my calculator. I'm going to do 5 divided by 2 plus square root of 5 divided by 2. So that would give me, I'm going to put an approximate here, 3.618, oops, 0.618, or x equals, let me just change this to a minus, 1.381. So any or all of these, to me, are acceptable. Some of them will be more useful. Like the last ones, these will be most useful when we start talking about graphing, because we kind of know what 3.6 looks like on a graph. It's, a little more than 3.5, a little less than 4. We don't really know what 5 halves plus the square root of 5 over 2 looks like on a graph. Cool. So we've seen two examples of this. Make sure you've taken your notes. In your binders, keep track of which ones you've done. On the back side, this is our practice on the quadratic formula. It says find the real zeros of each function below. So we've seen a good amount of examples. Notice over here, there's this case where this is kind of an issue. On number 2, that's a typo. Just to find the solutions of this equation, which kind of will be the situation where it's not initially equal to 0, so we may have to adjust it first, and then we can go on and apply our process. But the rest, you can just find the zeros of the equation, and it should work out great. All right, so try out those 4 problems. When you're done, check your solutions with the your intervention teacher, and then you are all set to show that you've done some extra practice on lesson 12a, finding quadratic solutions using the quadratic formula.